Okay, y'all, we're gonna look at our quiz corrections. The problems I'm doing here match up to the problems on your quiz, but the numbers are slightly different. And when you're doing this, the process will be the same, but the numbers are slightly different, so make sure you're double checking your answers. Okay, so on this first one, it says convert the following to scientific notation. I see that this is a really, really big number, so I know my decimal point is on the right. And I'm going to move that decimal point 1, 2, 3, 4, 5 spaces until there's just one number to the left of that decimal point. So I'm going to write this as 3.3 times 10 to the 5th, because that 5 is how many spaces I moved my decimal point. It's a really, really big number, so my exponent stays positive. Now on this next one, it's a really, really tiny number. I see that my decimal point is right here. So I'm going to move that decimal point 1, 2, 3, 4 spaces until it's between the 1 and the 2. So that becomes 1.2 times 10 to the 4th. And since this is a really, really, really small number, I'm going to make my exponent negative. So it's 1.2 times 10 to the negative 4th, because this is a really, really small number. On these next two, I'm starting in scientific notation and I'm going to expanded form. So here I see I have 10 to the negative 8. I know this negative means that this is going to be a really, really small number. So I'm going to move my decimal to the left 8 places. 1, 2, 3, 4, 5, 6, 7, 8, and I draw my decimal point. And every one of these blank spots, I'm going to put a 0. So I should have 1, 2, 3, 4, 5, 6, 7 zeros. Notice that the amount of zeros is 1 less than the exponent, because one of our moves is taken up by moving past that 7. So my final answer is going to be 0.1, 2, 3, 4, 5, 6, 7 zeros, 7, 4. And this makes sense. A negative exponent means we have a really, really tiny number. Now this next one, I have 4.3 times 10 to the 6th. Okay, if I see my exponent is positive, I know I'm going to move my decimal point to the right. I'm going to rewrite this here. I'm going to move this 1, 2, 3, 4, 5, 6. There goes my new decimal point. And any of those blank spaces, I'm going to write a 0. So 1, 2, 3, 4, 5. Again, notice our number of zeros is 1 less than our exponent, because we have to take up 1 space moving past that 4. Moving past the 3. So that gives me 4, 3, and then 1, 2, 3, 4, 5 zeros put in my commas. Okay. Now this next one we'll be doing unit conversion, and I forgot to grab the chart that helps us see unit conversion, so I'm going to do that really quick. You will also have access to this on the test. Okay. So I know I'm going from millimeters to meters. If I'm looking at my chart here, millimeters is here, meters is here. So I know that there are 1,000 milliliters in 1,000 millimeters in 1 meter. So if I'm looking at this, I'm starting with millimeters. So I start with 3,300 millimeters over 1 times, I've got millimeters on the top here, so I have to have millimeters on the bottom. And I just saw that there were 1,000 millimeters. So 1,000 millimeters in 1 meter. So these cross out, millimeters crosses out. If I multiply the top across, I've got 3,300. Multiply the bottom across over 1,000. If I plug that into my calculator, I should get, set up my fraction bar first, 3,300 divided by 1,000. Don't forget that decimal point. So it gives you a decimal answer, and I get 3.3 meters. Okay, which makes sense. If I'm going from a smaller unit to a bigger unit, I'm going to have fewer of the bigger unit. Next one, I'm starting in kilometers. So I always start with what I'm given over 1 times kilometers on the top here. To cancel it, I have to put kilometers on the bottom here and meters on the top. Now let's refer to my handy sheet to see how many kilometers are in 1 meter or how many meters are in 1 kilometer, because this is the smaller unit, right? So if I look here, I'm looking at, here are my meters, here are my kilometers. There are 1,000 meters in 1 kilometer. So there are 1,000 here, 1,000 meters in 1 kilometer. So I'm going to multiply these across. I'm going to cancel my units first. And then 9 times 1,000 should give me 9,000 over 1, because 1 times 1 is 1, which just gives me 9,000 meters. Again, which makes sense, because if I'm starting in a larger unit going to a smaller unit, I should have more of the smaller unit. Okay, now this last one's a little tricky because it's one of our 2-step conversions. So on this one, I'm given milliliters. So I start with 421 milliliters over 1. And if I notice here, I'm going from milliliters to kiloliters. So I'm going from one end to the other, which means I need to make a pit stop at my base unit. So this is going to be one of my 2-step conversions. So I'm going to start with milliliters first. If I have it on the top, milliliters also has to go on the bottom. With liters, my base unit, the pit stop unit, at the top. But that's not my final answer. I don't want liters, I want kiloliters. So I've got one more fraction to go. If I've got liters on the top here, I have to put liters on the bottom to cancel it out, and kiloliters on the top. Okay? So we've got the framework. Let's fill in the numbers. Between liters and milliliters, milliliters is my smaller unit, so that's where I'm going to start. I start at milliliters, and to get from milli to our base unit of liters, there are 1,000 milliliters in 1 liter. Okay, so now we're at our base unit. Between kiloliters and liters, liters is the smaller unit, and there are 1,000 liters in 1 kiloliter. So there are 1,000 liters in 1 kiloliter. And now I've gotten to kiloliters. I can cancel milliliters because there's one on the top and one on the bottom. Cancel liters. There's one on the top, one on the bottom. And now I'm just going to multiply across. 421 times 1 times 1 is 421. 1,000 times 1,000 should give me 6 zeros. Yeah. So I've got 1, 1, 2, 3, 1, 2, 3. And that I can just divide out. Again, if I put it in my calculator, set up your fraction bar. Y'all can't really see that, can you? 421 over 1, 1, 2, 3, 1, 2, 3. Don't forget your decimal point, and it should give you 0.000421. Now, we could write these in scientific notation if we wanted to. For the 9,000, I'd move this over 1, 2, 3. That would give me 9 times 10 to the third. And for this one, since it's a really, really tiny number, I could move this 1, 2, 3, 4. It'd be 4.21 times 10 to the negative fourth because it's a really, really tiny number. Don't forget your units. This is kiloliters. Okay, so that's our unit conversions. We're going to move on to percent error. So reminder, percent error is our formula. We have 2 things. We have approximate, actual and exact. Oh shoot, let me get my formula sheet, my notes from last class. Yeah, I'm going to pause here.